Now we are going to solve problems for BJT biasing. The first question, for each of the NPN BJT biasing circuits shown below, find IB, IC and VCE is the question. Okay. Now for the answers we need the formula, right? For IB, IC and VCE. Go to the formula sheet and look for the formula for each of these. This is a fixed base bias network. So for base bias network in here, you see the formula required are IB, IC and VCE. So IB is VCC minus VBE over RB. So we shall use it VCC minus VBE over RB. This is equal to 15 is VCC, 15 minus VBE is 0.7 over RB is 1 mega ohm, 10 power 6. 15 minus 0.7 is 14.3. This 10 power positive 6 comes to the numerator as 10 power negative 6 and it becomes 14.3 times 10 power negative 6 amperes. This is equal to 14.3 microamperes. Alright. Next, for IC, the formula is beta DC times IB. Beta DC is 200. 200 times IB is 14.3 times 10 power minus 6. This is equal to, on the calculator, 200 times 14.3. Okay, so 200 times 14.3 equals 2860. So 1, 2, 3 places to the left, 2.86. So this becomes 2.86 times 10 power positive 3, right? 2860 times 10 power negative 6. This becomes what? Minus 3 minus 6 minus 3, right? 2.86 times 10 power minus 3 amperes. That's equal to 2.86 milliamperes. So we have the value for IC now. Now VCE is what? VCC minus IC times RC. So VCC is again 15 minus IC is 2.86 times 10 power negative 3 times the value of RC is 1 kilo ohms, 1 times 10 power 3, so 2.86. 10 power negative 3 here and 10 power positive 3 here, they get cancelled. So 2.86, 15 minus 2.86 times 1 is 2.86. So 15 minus 2.86. 15 minus 2.86 equal to 12.14 volts. So now if you write them all here, IB equals 14.3 microamperes, IC equals 2.86 milliampere, VCE equals 12.14 volts. See, these are the answers. Alright, next question. Collector feedback bias. Again, go into the formula sheet and get the formula for the three things: IB, IC and VCE. Collector feedback. Here, collector feedback network. IC equals VCC minus VBE over RB over beta DC plus RC. Alright. So the same thing here. Look in this. you have all the required resistance values, voltage values, and beta DC. So IB if you want, first it's IC over beta DC. So we cannot calculate IB first, but we can calculate IC. IC is VCC minus VBE over RB over beta DC plus RC. Okay, only RC. So this is VCC 18 minus 0.7 over RB. RB is 510 kilo, 510 times 10 power 3 over beta DC is 200 plus RC. RC is 3.9 kilo ohms, 3.9 times 10 power positive 3. Now this is good because this term is in addition with this term. Both of them have the same power of 10, so they can be added. Now on calculator, 510 over 200 equals 2.55. This is 2.55 plus 3.9 is here, okay, plus 3.9 equals 6.45. the denominator is 6.45 times 10 power 3. Okay, so 18 minus 0.7 is what? 17.3. okay, 17.3 over answer equals 2.68 times 10 raised to the power. This positive 3 will go to the numerator as negative 3 amperes. So this is 2.68 milliamperes. Alright, this is it. This is your IC. Next, use this to calculate IB. So 2.68 times 10 power minus 3 over beta DC is 200. This is equal to, in the calculator you have the same value last. So this divided by 200 equals 0.013. So I'm milli, okay, 0.013 milli. So I'm going to write it as 13.41 times 10 power negative 6 amperes, 13.41 microamperes. Okay, now next is VCE. VCC minus IC RC. So 18 minus IC is 2.68 times 10 raised to the power minus 3. 18 minus 2.68 times RC is 3.9 kilo. They are going off. Now 2.68 times 3.9 equals 10.452. 18 minus answer, 18 minus answer equal to 7.54 volts. 7.54 volts. Now what is IB? IB equals 13.41 microamperes. IC equals 2.68 milliamperes, and then VCE equal to 7.54 volts. So all required answers are obtained, right? This is finished. Next, let's go for the next problem. The next problem is emitter feedback bias. Emitter feedback bias. The difference between fixed base bias and emitter feedback biases. In fixed base bias, we don't have RE, the feedback resistor, the negative feedback resistor, but we have here RE. So this is emitter feedback bias. Now for emitter feedback bias, we'll look at the formula sheet here. You have here emitter feedback bias. IC is VCC minus VBE over RB over beta DC plus RE. Okay, the emitter resistance is in here. So that is your IC. We can calculate IC, which is also equal to IE, is VCC minus VBE over RB over beta DC plus RE. Okay, now this is equal to VCC is 15 minus 0.7 divided by RB is 2.2 kilo, 2.2 times 10 power 3 over beta DC is 200 plus RE is 1 kilo ohm. Okay, again, since these two terms are in addition, they in equal powers of 10 is good for us. They can be added straight. So in the calculator, you're going to punch in 2.2 over 200. Okay, 2.2 over 200 equals 0.011, right? 0.011 plus 0.011 plus 1 plus 1 1.011 in the numerator. Okay, wait a minute. Yeah, I have considered RC, right? But the formula says RB I have to consider, right? RB is 500 kilo. So in the place of 2.2 kilos, I should have substituted, I should have applied 500 kilo, right? So moment. So 15 minus 0.7 divided by 500 over 200, right? So 500 over 200 equals 2.5 plus 1, 3.5 times 10 power 3 is there. 3.5 times 10 power 3 is in the denominator. 15 minus 0.7 is 14.3 over 3.5, right? So plus 1 you do, keep it, 3.5 you keep it in the calculator. So 15 minus is 14.3 divided by answer that's there in the calculator is 4.0857. So 4.09 we can say, right? 4 this is equal to 4.09 times 10 power positive 3 is going to become negative 3 amperes. 4.09 milliamperes is our IC. Next is, after finding IC, we are going to get IB. IB equals what? IC over beta DC. This is 4.09 times 10 power negative 3 over 200. 200 equals, we have in your calculator the previous answer divided by 200 equals 0.020. So this is 3 places to the right, 20.43 times minus 3 and here minus 3, 10 power minus 6 amperes. So 20.43 micro amperes, we have the answer. Next is VCE. VCE equals VCC minus IC times RC plus RE. You can get it from the formula sheet, okay? VCC minus IC times RC plus RE. VCC is 15 volts in this problem, minus IC is 4.09 times 10 power negative 3, okay, times RC is here 2.2 kilo ohm and RE is 1 kilo ohm. So 2.2 plus 1, 3.2 kilo ohms, 10 power positive 3. So this is in here, these two will get cancelled. In the calculator, 4.09 times 3.2. 4.09 times 3.2 equal to 13.088, right? And then 15 minus. So 15 minus answer equal to 1.912. So 1.91 volts. All right. So the three things, IC, IB, and so IB first. IB is 20.43 microamperes. IC equal to 4.09 milliamperes, and VCE equals 1.91 volts. So we have all the three required answers. We have solved this problem. Next is emitter bias. In emitter bias, we are having two power supplies, VCC and VEE, and this VEE is minus 12 volts, and the other information, hope you can see it clearly, with some amount of data gone, but still you're able to read it, right? Now emitter bias. For emitter bias, again we go to the formula sheet, and in the formula sheet, see, emitter bias circuit, you can add this formula in your formula sheet, please. Now I wrote the Kirchhoff's voltage equation for this loop. Okay, so that is VCC minus, I kept the voltage terms together, VCC minus VCE minus VEE minus IC times RC minus IE times RE is 0, right? Minus IE times RE is 0. So now if you want only VCE, it is VCC minus VEE minus IC times, IC and IE are the same, so minus IC times RC plus RE, right? So we have it here, VCC minus VEE minus IC times RC plus RE. Noted. And then use it for your calculation in this problem. Okay, now first thing is IE or IC equals minus VEE minus VBE over RB over beta DC plus RE. Okay, now minus VE is what? Minus of minus 12. Minus VB is what? 0.7 divided by RB is what? RB is 9.1. 9.1 times 10 power 3 over beta DC is what? 120 plus RE is what? 15 kilo. So 15 times 10 power 3. Again, this one, these two terms are in addition, so 10 power 3 and 10 power 3 is good for us for direct addition. Now 12 minus 0.7 is 11.3, we know. So only thing is we can, the denominator first, 9.1 divided by 120 equals 0.075 plus 15 we have. So 15.075 we have, okay, for the denominator. So 11.3 divided by answer equal to 0.7459. So 0.75 we can say, okay, 0.75 from the denominator positive 3 we have negative 3 here, amperes. 0.75 milliamperes we have, right? Next we calculated IE. Next is IB. IB equals what? IC over beta DC. So IC is 0.75 times 10 power negative 3 divided by beta DC is how much? 120 here, 120. Okay, 120. This is 0.75 divided by 120 equals 6.25. We can say, corrected to 2 decimal places, 6.25 times 10 power minus 3 from here and another 10 power minus 3 here. So 6.25 6.25 times 10 power minus 6 we can write it as, right? So this is how 6.25 times 10 power minus 3 by this division, and this 10 power minus 3 already existing, so 10 power minus 6.25 microamperes. This is IB. We have got IB. We got IB, we have got IC. Now we are going to calculate VCE. So the formula that we added, VCC minus VEE minus IC times RC plus RE. Okay, now this is given VCC is 16 volts and minus VEE is minus 12 volts minus IC is how much? 0.75 times 10 power negative 3 times RC plus RE, 12 plus 15K, so 27 times 10 power positive 3, right? So these two are going to get cancelled. 0.75 times 27, okay, 0.75 times 27 here, 0.75 times 27 equal to 20.25. so 16 plus 12 here, so this is 28 minus 20.5, okay, whatever we have here, 28 minus answer equal to 7.75 volts. 7.75 volts. All right, now we have all the three answers. What we need, let's write here, IB equals 6.25 microamperes, IC equals 0.75 milliamperes, and VCE equals 7.75 volts. We have all in place. Okay, so this problem is solved. Next problem is about voltage divider rule. Voltage divider rule, again go to the formula sheet. If the voltage divider rule problem says that your voltage divider is stiff, okay, for a stiff voltage divider use these formula, and regular voltage divider you can use it, okay, this one. Now first thing, whatever you need to find IC, IB and VCE, okay. For this again you have to, for finding IC or IE, you need VTH, V Thevenin and R Thevenin. So the first things to find would be first R Thevenin, then V Thevenin you need to find and apply it for finding IE, okay, and then VCE. Now in this here also you can include it, IB equals IC over beta DC. This is valid, okay, for this also, for this kind of network also. Now let's go. So first thing is what? RTH and VTH, right? Let's find RTH, R Thevenin. R Thevenin is what? R Thevenin is R1 R2 are going to be in parallel, R1 plus R2, R1 and R2. R1 is 22 kilo and 4.7 kilo is R2. So 22 times 4.7, both are kilo. So 10 power 3 times 10 power 3 is going to be what? 10 power 3. It's going to be 10 power 6 in the numerator, and in the denominator R1 plus R2. So 22 plus 4.7 times 10 power 3 only, okay. So now here use your calculator. 22 times 4.7, 22 times 4.7 equal to 103.4 divided by 22 plus 4.7, yeah, 3.87 times 10 power 6 here, 10 power 3 here, right? So 10 power 6 and 10 power 3, your 1 will get cancelled, 1 10 power 3 is going to be there, remaining 10 power 3 ohms. This is 3.87 kilo ohms. Next, what here we are going to find VTH, Thevenin. Thevenin is R2 over R1 plus R2 times VCC. Okay, R2 is how much? 4.7 times 10 power 3 over again 22 plus 4.7 times 10 power 3 multiplied by VCC 15 volts. Alright, here this is equal to 22 plus 4.7, 26.7 in the denominator, 4.7 in the numerator. Okay, 4.7 divided by 26.7 equal to this times the supply voltage 15 equal to 2.64. This is, and this will get cancelled, 2.64 volts. So VTH is 2.64 volts, right? Now so VTH equals 2.64 volts. Finished. Two things we have found. Now we are going to put them in the formula for IE or IC, which is equal to VTH minus VBE over RTH plus RTH divided by beta DC plus RE by formula. Okay, this is by formula. So VTH we got it to be 2.64 minus VB is 0.7, RTH is 3.87 times 10 power 3 because it's kilo divided beta DC 180 plus RE is 680 ohms. Okay, so if I add 680, then you have to convert it into ohms, right? Otherwise 0.68 times 10 power 3 is 680 ohms in kilo, right? So that we can add them straight. So in the calculator, punch in 3.87 over 180. 3.87 over 180 equals 0.02 okay, plus this one 0.68. This is your numerator. 0.70 times 10 power 3. Okay, so 2.64 minus 0.7, 2.64 minus 0.7 divided by answer equals 2.76. This is 2.76 times 10 power positive 3 will go to the numerator, 10 power minus 3 amperes. So 2.76 milliampere is your IC. Alright, next is IC equals IE equals. Alright, IC equals IE equals. Now they are same, right? Now next is what? VCE. You have to find VCE, or you can even find IB. IB by formula IC over beta DC. This is 2.76 times 10 power negative 3 over beta DC 180 equals 2.76 in the calculator as it is, divided by 180 equals 0.015 milli, right? So it's 15.36 micro. Okay, this is 0.015 milli, and times 10 power again another minus 3. So I would write 15.36 times 10 power minus 6 amperes. That's equal to 15.36 micro ampere. Alright, so 15.36 micro ampere. Got it. Next is VCE. VCE equals VCC minus IC times RC plus RE. This is equal to 15 is VCC minus value of IC 2.76 times 10 power negative 3 times RC is what? RC is 1.5 and 680. So 1.5 kilo plus 0.68 kilo. Okay, 1.5 plus 0.68 equals 2.18 kilo, right? 2.18 kilo. So 2.18 times 10 power positive 3. Okay, so in this multiplication, this and this will go. Okay, 2.18 kilo, and this one is 2.76 times 2.18, 2.16 times 2.76 equal to 6.01. 15 minus answer equal to 8.98 volts. 8.98 volts. 8.98 volts. Now all the three things that we have found in this question: IB equals 15.36 microamperes, IC equals 2.76 milliampere, and VCE equals 8.98 volts. So all answers are here. We are done with this problem set.